Okay, in this video I want to talk about logarithms with other bases. The logarithms we talked about in the previous video were all common logarithms, log meaning the base is 10. What we want to do now is talk about some other bases that we're going to see. So the next logarithm we're going to use is ln, and I'm actually going to use cursive L just so it doesn't look like the word in, but ln of x is going to mean that the base is e. So still the same formula, just a different base. So instead of log, ln, and then the base switches from 10 to e. And remember, e is approximately 2.7182818, I don't even know, whatever, some random decimal, about 2.7. This thing is called the natural logarithm. So common, it's base 10 is the one that's commonly used because we like looking at what's the power of 10, how many digits does a number have is associated with the common logarithm. The natural logarithm comes up naturally when you're looking at things like biology and compound interest and various situations. Anyway, and then there's the third situation that's if it's neither one of these, then whatever, we don't have a special rule for it. We'll just write log and then a particular number of x. So the particular number is going to be our base. So this would be log base a. Okay, so what that means is any logarithm we can write as log with a particular base. So log is really a log where the base is 10, and ln is really a log where the base is e. Okay, so if you wanted to, you could just always use this notation, log, and then the subscript is the base. So the number down low, the number below other numbers is the base. Okay, let's look at some examples. Find natural log ln of e to the 5th power. Okay, so that means we're saying y is equal to ln e to the 5th. And just like with our common logarithms, we think about that as being a Jeopardy question or a question backwards. We're saying e to the power y is equal to x, and this number right here is x. So e to what power spits out e to the 5? Well, just stare at these two things. What does y have to be if the left side equals the right side? Y's got to be 5. And so that means 5 is equal to natural log of e to the 5th. So our answer is 5. Just be really careful on that one. You don't want to say your answer is e to the 5th. Your answer is just the number 5. That's it. So natural log of a power of e ends up being really easy. We'll come back and talk about some special formulas for logs later, but for now, that's an example. Let's try another one. Find log base 2 of 16. So if y is equal to log base 2 of 16, then we're asking ourselves, the base is 2, the exponent is y, and the answer is 16. So 2 to what power spits out a 16? So just like all our common logarithms, where 10 to what power spits out this x, now our other logarithms are going to be a to what power spits out this x, or e to what power spits out this x. So we just have to try and remember our powers of 2. I might off to the side write down some reminders. 2 to the 1st is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. So apparently this is saying 2 to the y is equal to 2 to the 4th. So apparently the missing exponent, or the exponent we're trying to find, is 4. So the log base 2 of 16 is 4. I guess I should have written down at some point how you say this. Log base 2 of 16 is equal to 4. So we call this number the base because it's the base of the exponential equation. Okay, let's try some more. Let's try log base 9 of 3. Okay, let me see if I can skip writing this and jump straight to writing this. So our base is 9, our answer is 3, and so the missing exponent should go there. So 9 to a power, base and exponent should go together. 9 to a power spits out 3. Well, square root of 9 would be 3. And then we just have to remember, how do we write the square root as an exponent? The square root is the 1/2 power. And so if I'm trying to find y, apparently y is 1/2. So the answer here is 1/2.